I'm going to show how to improve the current consumption of simple peripheral running on CC2640 out of Launchpad. So normally a Bluetooth peripheral is 3-volt powered using either coin cell battery or AA battery. A good way to know if your Bluetooth peripheral current consumption is very low is to measure the CC2640 RTF low power standby mode or and shutdown mode. So if your Bluetooth peripheral able to achieve current consumption very close to low power mode of standby mode and shutdown mode, then your battery would life would last very long. So according to datasheet, the standby current is 1.1 microampere. So the standby current is not steady because during this standby mode, there's a DC recharge pulse happening that to retain the data at RAM. However, the shutdown mode current is steady. So I'm using a budget digital multimeter Unity UT61E to measure current consumption. Using this multimeter, I'm not able to measure standby mode, but I'm able to measure shutdown mode. Texas Instruments recommends this equipment for measuring Bluetooth low energy current consumption. So this is a DC power analyzer, Agilent rebranded to Keysight. So this can measure in great accuracy, transitioning from low power mode to running mode. But this is very expensive. So what I'm going to do is what I did was modify the simple peripheral to go to standby mode to go to shutdown mode after 5 seconds. So what I did was so originally the clock what happened is the clock is used when there's a Bluetooth connection, it would copy the characteristics tree value to characteristics for simple profile. But I repurposed this to instead at initialization um, start at initialization and then after 5 seconds disable the advertisement, set pin for wake up, and then go to shutdown mode. So I will flash the X file of, of this modified simple peripheral to CC2640 out of Launchpad and then measure the current consumption. So I flashed the hex file to the CC2640 out of Launchpad, removed the jumpers at XDS110 isolation headers P4 and also the jumper at P10, and then connected the Launchpad to Unity UT61E DMM. So I'm going to set the dial to milliampere. And then turn on. So after 5 seconds, it will go to shutdown mode. Now it is shutdown mode. So the current consumption is around 50 microampere and it's still going down. Our current consumption measurement for shutdown mode is 50 microampere, which is very high. According to datasheet, the shutdown current is 100 nanoampere. So what could be causing this high shutdown mode current consumption? And normally what causes this is additional circuitry or open peripherals. So from the schematic diagram, what is connected to the CC2640RTF is the external flash. So what are we going to do is call board shutdown external flash at simple peripheral init. So what it does is basically send the shutdown command to the SPI external flash. So what it does is send the shutdown command to, first wake up the external flash, then send the shutdown command to the external flash, and then close the SPI pins. Okay, so we call that, and then what else could be causing this high current consumption? So what we use, simple peripheral, is we print to the serial console. So meaning we're using UART, using display printf. So by calling display open, we open the UART, and then throughout the code we call display print, which prints out to the serial console. So this causes the another cause of current consumption. So what we're going to do is all UART related code or display printing, we would put a if not defined disable all. So and then we will set the predefined at compiler predefined settings. Okay, we're going to do that, and there's a lot. So okay, so fast forward. I have already done the modification. I called board shutdown external flash at simple peripheral init. Then I set display disable all predefine symbol here. Then all display related code I put if not defined display disable all. So starting with main, and then at cc2640r2 launchxl.c board file, I also set the drive strength of red LED and green LED to minimum. Then a simple peripheral all display related code, and I put if not defined display disable all. So if you want to enable printing again, just unset the display disable all predefined at here. So just put X. Okay, now I'm going to rebuild all and generate hex file and flash the hex file at CC2640 RTF flashpad and then measure current consumption again. Okay, so I flashed the hex file and connected the Launchpad again to the DMM in series for measuring current. I set the DMM dial to milliampere and turn on. So after 5 seconds, it will go to shutdown mode. Okay, I set the dial to microampere, and now the current is 0.1 microampere or 100 nanoampere, which is according to datasheet. So now your Launchpad can achieve this shutdown mode current according to datasheet. So if you add additional circuitry to the Launchpad and the current increases, you know that additional circuitry causes the increase in current consumption.